Okay, it is now time to look at the proper way to search a parameter like max depth to find the optimal result. So I'm going to give us a new header here, and let's call this GridSearchCV, because that's what we're actually going to be using. I didn't do a top header or title it. We should title this. Just call it like decision trees. It's gonna be our decision tree notebook. This is in particular classifier, so we could put CLF too. Okay, so let's jump right into it. So I'm telling you that grid search is what is used. So the idea is this: you don't have to like input like all the parameters every time, like max depth 5. Now I'm going to rerun the whole model and write my own function max depth 4. Grid search will handle that for you. So let's look at how to do it. So it's from sklearn.modelSelection, okay? And you're going to import GridSearchCV, okay? And note CV here, that stands for cross-validation. We've talked about that, like cross-val score. So it has cross-validation built into it, which is really nice. All right, so now we're going to start by setting our parameters, okay? And I'll label everything here. So import grid search, I guess we'll say CV. And next we set parameters. You could say set grid of parameters. This is what we're going to check. All right, so it's a dictionary, and it's typically called params. These are technically hyperparameters. Hyperparameters are like they're set before the model is built, right? What do I mean? Like here, when we pick max depth as 8, that's like a setting before like the model fits to the data, right? There are additional parameters that models use once they look at the data to do the actual fit. Okay, so inside of the dictionary, you put in quotes the name of the parameter. In this case, max depth is what it's looking at. How deep, how many branches are trees. And we can choose the full range, okay? We can choose none, which is a default. And what that means is you can just, as many as it takes, we've seen that already. Maybe that's the best score that we can get. Or we can do smaller values, right? Small ones don't take that long. So, let's just do a full list. 2, 3, 4. You can end up like, look, it's going to check each one 5 times, split the data 5 times. So I start to typically count up, like meaning but like every other. And then maybe like, I don't know, maybe I'll stop there. And the idea would be this: if the best result is like 15, well, we can then do it again and look in that direction. If the best result is 10, I could also look at 9 and 11, right? So it doesn't have to be totally thorough. I think I'll take out 2 in this case. If the best result was 3, we could look at 2. So this is 1, 2, 3, 4, 5, 6, 7, 8 different possibilities. But again, CV 5 models each, so 40. And as you can see right from our image, it's clear that if you like only have 2 splits, well, the model's going to build much more quickly than if you have 15, right? Okay, so that sets the parameters. Next, we're going to initialize model. Initialize ML model, you could say. So that's done the same way. And so we'll just say model equals decision tree classifier. And now you don't actually put the max depth in here, okay? This is just telling what model we're going to use. And we use it in the next step, which is the big one. We're going to initialize GridSearchCV model. You could say grid search model or something for short. I don't know. Whatever, GridSearchCV model. So this is actually the model that we're initializing. I'll call it grid, and it's going to equal GridSearchCV, okay? Now, let me just explain something here. This is like a machine learning model, okay? You treat it like a machine learning model, like a cross-val score type of thing, okay? So we're going to still fit it to the data and score it, okay? But first, we need to set it up. We put in the model, then the parameters, okay? After the parameters, the scoring by default should be accuracy, but I just want to put in some things. You can change the scoring metric here. And you can even change the number of folds here. I think 5 is the default. I tend to use 5 on average. Okay, so that's basically initializing the model with the decision tree in there. And now what we do is we fit model to data. So look, this runs its own cross-validation. So, you could just run it on the, sorry, it's not model here, it's grid.fit. You could just do X and Y. You could do smaller set, X train and Y train, and hold out the test set for the very end, okay? That would be like a standard way to do it. If we're doing it right, that is what you would do, because the idea is that the test set you withhold until the very end. So if we're really trying to build an optimal model, we can do X train and Y train. And we have a big data set, so it won't make too much of a difference. Okay, now, the model has been fit here, and here's what it does. It's like a double CV. It runs CV of 5 for each of these 8 cases. And so we want to know, yeah, but which one got the best score? Okay, which parameters is it? And we can get it. Okay, it's best parameters. So basically, to show the best parameters, what you do, you've got to call out the model grid dot it's just best underscore params underscore, double underscore there. Okay, and that should give it to us. Let's try now. This is going to take some time, right? Because press Shift Enter. See how it's the green arrow shows it's here on the fitting. And the reason why it's going to take some time, well, it actually came back pretty quickly. Why do I think it's going to take time? Because against 40 times, right? We got 30,000 rows, but we're doing 8 of these each times 5. And we got that it returns that a max depth of 8 is the best option. Okay. Now you can see there, we didn't actually include 7 and 9, right? So if you want, you can do it again. And, needless to say, we should be writing a function to do this. And some functions that you write, you might not use again. Some you may use a lot. Look, a grid search function, this is going to be used a lot. So I'm going to encourage you to take a moment on your own and actually turn this GridSearchCV into a function. So what we're going to do is write a function for GridSearchCV that takes, now what should the input be? The input should be the parameters, okay? And if we want it to be like a thorough function that we can use, we could also change the model. Now in our case, this is just a study of decision trees, so we could probably just leave it. So we'll just say that takes parameters as input and returns best ones. Okay, so I will come back and show you how I did it. Take a moment and work on it right now.